Dyscalculia, TD 494, Spring 2017. Demands of math. Success in math requires visual and verbal abilities, spatial skills for understanding shape, symmetry, relative size, and quantity, linear skills for understanding the sequential and ordered symbols and representations found in the number system, and algebra. Developmental dyscalculia is a brain-based disorder that causes difficulty for students in their sense of numbers and math concepts. It's identified in about 5 to 6% of the school population, and it's a frequency similar to those of developmental dyslexia and attention deficit hyperactivity disorders students. Unlike these, however, it is as common in females as it is in males. Students are between the ages of 6 and 14. These demands are important in the understanding of the difficulties faced by individuals with dyscalculia. Some of the indicators of dyscalculia are the inability to comprehend quantities, large or small, poor number sense, and inability to estimate whether a numerical answer is reasonable, immature strategies, for example, counting all instead of counting on. Students are unable to say, begin from 3 and count on to 4, 5, 6. They instead have to return all the way to 1 and try and count all numbers to the number expected. They have an inability to notice patterns. Indicators also are inability to generalize, slow processing speed, difficulty with language, poor memory for facts and procedures, difficulties in word problems, and multi-step calculations. The last characteristic may also be influenced by the effects of dyslexia and the inability to understand language and difficulty expressing in words quantity. Identifying and assessing for dyscalculia can be done through observation of students in the classroom. This can be done through standardized tests and assessing student scores with potential and with their performance. The Dyscalculia Screener devised by Brian Butterworth is used, and this is a computer-based test that measures reaction times, which are then compared with other measures that have been found to be associated with the condition. The neurological test battery for number processing and calculations in children is a test that assesses number concepts and arithmetic procedures. This test is used by professionals only. Who can diagnose? A pediatrician, child and adolescent psychiatrists, occupational therapists, and educational professionals. These are all dependent on what characteristics the students show and then can be tested by those who are qualified and knowledgeable to diagnose. Areas affecting the brain from developmental dyscalculia. Begins with focus, concentration. It's a skill related to the pattern of cognitive deterioration linked to dyslexia, and also related to inhibition, which affects the mind's sharpness, making it more difficult for the child to learn math. Divided attention. This skill is important as it allows for multitasking. Students with math disabilities present problems when responding to a stimulus because they are unable to focus. They get distracted with irrelevant stimuli, and they tire easily. Working memory. This cognitive skill refers to temporary storage and the ability to manipulate information in order to complete complex assignments. Some difficulties as a result of this may be trouble following directions, forgetting instructions and tasks, low motivation, incomplete memories, being easily distracted, not remembering numbers, and delayed mental arithmetic. Short-term memory is the capacity to retain a small amount of information during a short period of time. This mental deficit explains the inability to carry out math assignments. The problems present themselves when they calculate or attempt math problems. This is also related to the inability to remember numbers or multiplication tables. Naming implies the ability for a student to recall a word or number and use it later. Students with dyscalculia have difficulties remembering numbers because their ability to process information is deficit. Planning is low levels in this cognitive skill implies difficulties in planning and making sense of numbers and exercises. This inability to anticipate events or outcomes prevents the student from correctly completing the exercise. Processing speed corresponds to the time it takes for our brain to receive information, like a number, a mathematical equation, a problem, understand it, and respond to it. Children that do not have any learning difficulties complete this process quickly and automatically, while children who have dyscalculia need more time and energy in order to process this information. Impact on learning affects the core numbers for students with dyscalculia. It affects the number sense, estimating, assessing difference in numerical quantity, understanding math symbols, place value, and placing numbers on a number line. The ways to help this are activities that focus on the connections between numbers as quantities and symbols. Practice rounding numbers and estimation. Use base 10 materials to support understanding of numbers. Use 10 frames and 5 frames. Encourage verbalization. Explore how numbers relate to each other to develop number sense. This is an example of how to show a student the relationship between the number 3 and the amount of 3 that is in the circle, making connections between numbers as quantities and symbols. Estimation. Use manipulatives by putting a handful of manipulatives on a table, allowing the student then to estimate and then group them into tens. The impact on learning with students with dyscalculia for reasoning, understanding relationships and mathematical concepts. They have difficulty understanding multiple steps, problem solving and decision making, and recognizing patterns. Ways to help. Explicitly demonstrate the link between math and everyday situations, using money, time, making change are all examples that can be used. Represent math concepts with pictures and diagrams. Develop metacognitive skills. The impact on memory is found with the short term. Use chunking and repetition and table squares. With working memory, give questions based on what students know so that they can build upon that knowledge for new information. Long term, you can show them how to use a multiplication. Assistive software is a great tool to use for students with dyscalculia. Software that helps children learn basic math facts is beneficial for dyscalculia students. Professor Diana Lauren, a member of CN from the Institute of Education, University of London, said in a University College London article that results from neuroscience and developmental psychology tell us that dyscalculia learners need to practice far more number manipulation tasks than mainstream learners. Adaptive, game-like programs that focus on making numbers meaningful, emulating what teachers do, can help learners practice beyond the classroom and build the basic understanding they need to tackle arithmetic. In summary, it is good to keep in mind while teaching students with Dyscalculia, to focus on understanding. Use concrete materials to help link mathematical symbols to quantity. Start at a level which the child is comfortable at, so that they experience some success, and slowly move to more difficult areas. Provide a lot of practice for new skills, concepts. Reduce the need for memorization. Remember, it is not beneficial, and especially in the beginning. Make learning as active and fun as possible. Engage the students in the process. In conclusion, dyscalculia is a disorder that is relatively new in the field of mathematics. It is a hindering disorder that causes students the inability to understand the operations and process of fundamental mathematics. It takes an educator, understanding, and patience to help students through. Although the cause of the dyscalculia is not clear, there are strategic strategies that have been proven to help students with dyscalculia achieve success and overcome obstacles caused by dyscalculia, and are able to lead productive and fulfilling lives.